Hey, welcome to another episode of AWS Cloud Bytes. I'm your host, Bhavesh Kumar. I'm a certified AWS Solutions Architect professional and a DevOps engineer professional. If you are new to the channel, please subscribe and click the notification bell icon. As usual, the agenda is to check out AWS news and solve some questions. Today's focus will be on understanding questions suitable for Solutions Architect Associate and Pro level exams. Let's talk about some updates in the AWS world. Okay, this week, Amazon CloudWatch Lambda Insight is going to support AWS Lambda container images, and this is under GA. If you don't know anything about AWS Lambda container images, you should visit this blog, AWS News blog. And if you see, it was somewhere in December 2020. An additional support was given. Now you can package deploy Lambda function as container images up to 10 GB in size. So if you look at this application, this is a basic Node.js application using some PDF libraries, doing something on this piece of code. And then if you look at it over here, they're using Node.js 12 and packaging it as an application here, as an image over here. Now this image could be run in Lambda. So this is a good news that CloudWatch Lambda Insights will be able to monitor, troubleshoot, and optimize performance of the AWS function that is packaged as a container image, packaged and deployed as a container. Lambda functions deployed as container image benefit from the same operational simplicity, automatic scaling, high availability, and native integration with many other services, which is available with a deployment package that is also zip archive. There is another example telling you how to enable the Lambda Insight. So you can create a Docker file. This is an example on Amazon Docs. So you can create, this is referencing Python 3.8 library, an image from ECR, AWS ECR, public ECR. And then it is doing some stuff on top of it, copying and exposing index.handler. And then you can create a handler file over here that is returning a message, hello world. You're creating a repository, building it, logging into the repository, tagging it, and pushing it to the ECR, basically. Now, this image is available in the ECR, and then you can assign this policy to your executioner function, CloudWatch Lambda Insight Execution Role Policy, after you have created a function, a Lambda function. So these are like an example steps given over here. There are more details. So if you want to run through this, enabling Lambda Insight on a Lambda container image deployment. The next news is coming from IGMP, Internet Group Management Protocol. Multicast on AWS Transit Gateway is now available in major AWS region worldwide. AWS Transit Gateway supports IGMP multicast in major regions worldwide. It includes US East, Canada, South America, EU. Looks like almost all the region primarily. IP multicast on AWS Transit Gateway helps customer build multicast applications in the cloud and distribute data among thousands of VPCs. Customers no longer need to configure static multicast groups, sources, and receivers when building a multicast network in AWS. AWS Transit Gateway dynamically adds or deletes multicast members based on IGMP protocol interactions. Many on-premises multicast applications require IGMP to dynamically add or remove multicast group members. With native IGMP support on Transit Gateway, AWS Transit Gateway, customers can easily lift and shift such workloads to AWS Cloud without requiring a change to application or network configuration. So this is a pretty good thing if you have to do some kind of migration that requires these protocol. If you want to look in details, multicast on Transit Gateways, there is a section under VPC, Transit Gateway section. And you can go there and look for multicast on Transit Gateway. So multicast is a communication protocol for delivering a single stream of data to multiple receiving computers simultaneously. So it's like a broadcast. And it supports routing multicast traffic between subnets of attached VPCs. It serves as a multicast router. For instance, it's sending traffic destined for multiple receiving instances. And the concept-wise, like multicast concept-wise, they have some key concepts written over here. Multicast domain, what is a multicast domain, what is a multicast group, IGMP, multicast source, and multicast group member, certain considerations. So I would suggest you to visit this page and read the documentation in detail. That will be helpful. The next news is from Amazon EC2 autoscaling. It has introduced warm pools to accelerate scale out while saving money. So what is happening is when you run an EC2 instance, there is a initialization process, initialization step that happens. And using these warm pools, you can have EC2 instances available that are pre-initialized and in the stop state. So that's what this news is about. This will allow you to have fewer continuously running instances. You can just stop the instances with the pre-initialized EC2 instances available. And with the warm pool, you can actually save the compute cost because your instances are already initialized and are in a stopped state. So until they are stopped, you're not charged for the compute. Warm pools are a good fit for application, having some time-consuming initialization step, like if you have to load some kind of static data or you have to run some custom scripts, all those things, if it is taking more time, it will be a time saver, as well as it will take less time to be available for providing services to the customer or the consumer. Now, they can work, the pre-initialized instances can serve traffic in as low as 30 seconds. Yeah, I think this is pretty good for applications that need some kind of quick response or quick compute availability, even though they have a lot of steps in initializing their application or some kind of static data load is required. So a good move by AWS. I think this is going to be really good news for people who work a lot with Amazon Athena, making all those queries and executing those queries. Having a query execution plan will help in fine-tuning the queries. So this news is from 8th of April. Amazon Athena now presents query execution plans to aid tuning. Now, if you look at the execution plan, I have opened this particular page over here. So there is an explain statement in Athena. Now, there are some consideration and limitations. I'm not going to be deep diving on that. But what exactly it is showing is that with the explain and query over here, the output is something like this. It gives you some analysis about partition value and details about it. Now, there is another explain statement here, and the format is a graph. So it gives you an output like this: plan node 1, 2, 3, 4, 5, 6, all those, depending upon what kind of graph it is making. This query with an explain format graph viz is giving this output. But there is another open source tool that is linked over here. Will actually show you a graphical representation of the same query plan, as we used to have this feature in SQL Server from a long time. In this section, we are going to solve some AWS questions. Let's try to understand the context and find some right answers. Question: an analytics company is leveraging AWS Cloud to process sensor data. So this is sensor data, just keep in mind, from the field devices. So it's something outside of a life sciences company. The company store the IoT sensor data in Amazon DynamoDB. So this is our storage in Amazon DynamoDB tables To detect abnormal behaviors and respond quickly, all the changes to the item stored in DynamoDB must be logged in near real time. So this is saying near real time. As an AWS certified solutions architect professional, which of the following solutions would you recommend to meet the requirement of the given use case so that it requires minimal custom development and infrastructure maintenance? So what are we looking for? We are looking for IoT data, which is clearly mentioned here, and even with this, sensor data is basically IoT data only. So it is IoT data, it is stored in DynamoDB tables, and we need to check for abnormal behavior and respond quickly as soon as maybe it is in near real time. It is not saying real time, it is near real time, which is around a little delayed by real time, but almost real time. So as a solution architect, you want to do almost zero custom development or minimal and infrastructure maintenance. I'll give you like 30 seconds to go through these points and try to find an answer. Then I'll go one by one on each point and we'll try to find the solution. Okay, let's look at first option. Now it says set up cloudtrail. So you can set up cloudtrail to capture all API calls that update the DynamoDB tables. Leverage cloudtrail event filtering. This is event filtering here to analyze abnormal behaviors and send SNS notification in case of anomalies are detected. So looking at this option, first of all, one thing is you can use cloudtrail to capture API calls for DynamoDB as events. The calls captured include basically the calls going through console or using an SDK if you go, or an API call if you're making using any other application that you've built using an SDK. So basically an API or console. Making any DynamoDB calls, you can API calls, you can actually capture that. If you create a trail, you will have continuous delivery of cloudtrail events. If you create a trail, you can enable continuous delivery of cloudtrail events to an S3 bucket. These events will include DynamoDB and other events that are there, any kind of API calls. The cloudtrail does not support get record API for DynamoDB stream, so you cannot use this to capture the actual record. You'll know there was a request, but you cannot see the actual record, what is happening. And on top of it, you cannot use cloudtrail event. So this one, the event filtering, you cannot use to filter anomalous behavior based on the filtering that mechanism that we have, because the filtering is all about suppose read only or based on event source or event time, etc. So this option doesn't look like is going to be a right option, so I'll just strike it out. Okay, the next option is set up the DynamoDB stream over here, set up the DynamoDB stream to capture and send updates to a Lambda function that outputs record directly to Kinesis Data Analytics, KDA, detect and analyze anomalies in KDA, and send notification via SNS. So one thing to notice, if you know the workflow, I would suggest you should read through Kinesis Data Stream, Analytics, and Firehose, and what they can connect with, what can be their inputs, and what kind of outputs they can connect to. If you have that knowledge, you can straightforward see that Kinesis Data Analytics and Lambda. Kinesis Data Analytics can accept source, streaming source, following streaming source. Um, that is KDS, which is Kinesis Data Stream, and KDF, which is Kinesis Data Firehose delivery stream, basically. So this is straightforward, no. Um, so we can strike it out. Let's talk about option D over here. It says configure event pattern in CloudWatch events to capture DynamoDB API call events and set up a Lambda function to target as a target to analyze anomalous behavior. Send SNS notification when anomalous behaviors are detected. Now in this, basically, if you look at the event source, when we create an event source, CloudWatch event service does not offer event type for DynamoDB, as it is dependent on cloudtrail to get the relevant API call information. And as we already discussed that cloudtrail cannot capture the DynamoDB stream record, as the get record API for DynamoDB stream is not supported. So this option is again not a correct option. We just left with one option over here. Okay, let's look at the last option here. Set up a DynamoDB stream to capture and send updates to a Lambda function that outputs records to KDA, which is Kinesis Data Analytics, via Kinesis Data Stream, detect and analyze anomalies in KDA, and send notification via SNS, which makes sense. Like you have a data stream, Kinesis DynamoDB stream, basically. So DynamoDB stream can store all the modification in last 24 hours to be processed using a Lambda function. And the Lambda function can actually output the response to KDA using the Kinesis data stream. So once the stream is processed, you can send notification by an SNS topic. So as soon as data comes into DynamoDB, DynamoDB stream is populated, which is a queue basically, is populated and is available for next 24 hours. There can be one or more Lambda listening to this queue, and then the Lambda can send this to another DynamoDB for copying, or it can send it to Kinesis Firehose, or it can send it to a Kinesis data processing layer, which is basically Kinesis data stream, and then there can be analytics on top of it that can be performed. Analytics can also be performed from Firehose to Redshift, and then you can have QuickSight on top of it. So it's all these integrations are important to know. What all things can integrate with what service and what application can integrate with each other. So as a solution architect, on a professional level at least, in this exam you will be tested on all those integration. So I would suggest you to read through that and try to see what integrations doesn't make sense. Let's look at the second question. A diagnostic imaging company. A diagnostic imaging solution provider uses AWS Cloud to run its healthcare data flows through more than 100,000 medical imaging devices globally. So there are like 100,000 medical devices imaging devices globally. The solutions providers store close to 1 petabyte of medical imaging data, and this is stored in S3. to provide the durability and reliability needed for their critical data. A researcher at the company is trying to upload a high resolution, so it's a resolution image into S3. It's trying to upload in S3 using public internet. So those are kind of keywords. The image size is around 2 GB. The research assistant is using S3 transfer acceleration for faster image upload. The use of S3 TA did not resulted, so it didn't resulted in any accelerated transfer cost. Given this scenario, which of the following is correct regarding the charge for this image transfer? Take a break, look for 30 seconds, try to find an answer, give a reasoning behind it, and then we can come and solve it. Let's read through some of the options. Let's talk about maybe C. We can start with C. The research assistant only need to pay S3TA transfer charges for image upload. So since the S3TA did not result in an acceleration in transfer, basically they didn't use any S3TA while doing the upload. So because it wasn't used, there won't be any charge. So this one is not correct because they cannot charge. AWS will not charge until S3TA was used. Okay, the next option is option B. Let's see. The research assistant only needs to pay S3 transfer charges for the image upload. So if you know S3 as a service, when you upload something, it's never charged. It is uploaded from internet and you're uploading data. So that data upload never charged. When you download, that is when you're taking data out of S3, that is charged. So in this case, there won't be any option B. The research assistant needs to pay both S3 transfer charges, S3 TA, as well as S3 transfer charges in this case. So S3A never happened. S3 TA wasn't consumed. The transfer acceleration wasn't used, so no charges. S3 transfer charges, something coming from internet to S3 is not charged. So this is another wrong option. The research assistant does not need to pay any transfer charges for the image upload, which is the right answer in this case. This is the end of the show. Thank you for watching. Please click subscribe button and press the bell icon for notification on new episodes. This is your host Bhavesh Kumar signing off. Thank you. Take care. Bye bye.